has more than a decade of experience implementing large-scale floodplain restoration projects. He's developed a proficiency in hydraulic modeling and using LiDAR to improve restoration efficiency. And part of Ryan's ethic, his restoration ethic, was shaped by years of working with the Yakama Nation, where he was also like our right-hand partner on large projects in the Tianaway Community Forest. And we're continuing that work with Yakama Nation, but we've missed getting to work directly with Ryan. Ryan is interested in improving climate resiliencies in landscapes by coordinating and implementing forest health thinning projects and using thinned woody material to restore degraded streams and river networks. Ryan is an FAA licensed drone pilot, which has expanded his ability to analyze project effectiveness and communicate with clients, and is super impressive all around. He has a BS in Fish and Wildlife Management from Montana State and a certificate in river restoration from Portland State University. So thanks for coming, Ryan. Zach Zacavish will lead us off tonight. Zach is a project manager with Mid-Columbia Fisheries and an Appalachian mountain man. We were excited when Zach joined our team in 2020 because he's fun and smart and has a lot of great skills. Zach has an MS in Fisheries Biology from West Virginia University. Salmon and bull trout and the Pacific Northwest snowpack drew him away from his beloved Appalachian Mountains. There, he studied wild American ginseng, focusing on brook trout ecology, flow regime changes this is too hard. Flow regime changes on habitat availability. Zach is awesome. You're gonna love hearing him present. He likes to look at the big picture and tie things together on a landscape scale. And he also is an FAA licensed drone pilot. So before we start, a little bit of housekeeping. We'll have time for questions and answers at the end. And you can type your questions in the chat box or ask at the end. We'll probably have everyone muted during the presentation. So if you want to ask a question at the end, we'll unmute you, but you may also have to unmute yourself. And if you called in on the phone, mute yourself on the phone. And then I think most people know in Zoom, you can change the view from like who's talking to which or everyone, and who's talking is really nice for a presentation. And we have closed captioning enabled, so don't be surprised if you see captions pop up on your screen. I think that's it for the housekeeping. So we're super excited that you're here. And with that, I'm going to turn it over to Zach.
All right, perfect. Thank you for the introduction. And thanks for everybody coming out for this. I'm really excited about this topic. And I'm just going to kind of give you two warnings beforehand. Margaret kind of touched on this. I'm from Appalachia and I'm very excitable. So my enunciation and my rants could get a little fuzzy. So bear with me as I kind of go through this overarching drone discussion. And again, many of you are familiar with the content that drones could produce, but there's still so many aspects of this technology that have yet to kind of be explored when it comes to restoration, particularly as drones get lighter, cheaper, and just more efficient. And combine that with software development, the ease of processing, the accuracy that it's able to generate on the landscape kind of gives you this overarching ability to monitor at a landscape scale, kind of tying in that big picture to like what we are all focused on is like getting these systems back to where they should be and producing the fish that we all care about. So in my portion of the talk, I'm going to kind of go into a brief background of aerial photos, simplify of how these two-dimensional and three-dimensional models are generated. You'll often, Brian and I will both refer to those as orthomosaics, and kind of showcase a specific example in which Mid-Columbia Fisheries is utilizing a drone and kind of highlighting the efficiencies, insights, and providing that general drone stoke that these pictures and this data could kind of give us. While possible, none of the following content is going to be National Geographic style. Hopefully my background picture gives that to you. So kind of with any new technology, there's a general progression that investors, company, and the general public follows. You kind of have this innovation trigger. You have a huge peak of expectations. And that's kind of a good thing to keep in mind when we think about this. And a really good example of what we're experiencing now is the Chat GPT, or the AI producing work for people. So it's just like keeping that in mind is like where we're at, is like knowing where you're at in this sequence and this graph is kind of important when we think of implementing technologies in anything. So kind of going further back and relating to aerial photos, the first aerial photo was taken in 1858. And while that photo is no longer, like, you can't find it, this photo is from the 1860s, and it depicts Boston, titled as "An Eagle and Wild Goose Would See It," which I think is amazing. I wish I would have titled the talk this. But the crazy thing about this, from these photos taken in 1858, 1860, it took nearly 100 years for the first aerial photos and the first methodology of using them in natural resources to be published. And that happened in 1954, looking at land class. And then a more robust method was developed in 1956 that actually took that methodology from 1954 and looked at cereal crop diseases. So in reality, us using drones is nothing new. It's been like using aerial photos has been around for 100 years, if longer. So like we're not really pioneering anything new here. We're just kind of adding a flair to it and adding some background capabilities with math and computers that make these photos possible to generate data. So kind of like thinking back at that graph of where we're at in it, I kind of think as it relates to natural resources, I'm going to argue that there's a natural lag in adaptation due to budgets, methodologies, the standard process to get technologies into the field, peer review methods. All this is kind of like, we kind of miss out on that peak of inflated expectations phase that I showed earlier. However, what we do get is this long history of using aerial photos that help curb those expectations, have methodologies in place for digitizing, interpreting those photos. And this kind of leads to faster adaptation. However, it wasn't until 2006 when the first license were issued by the FAA for civilians to use airspace. And you kind of see that graph not really change that much from 2006 clear until 2013. And kind of what happens here is we see a drastic increase in the availability of drones and the price reduction in the kind of the upfront cost to get into flying a drone around. In 2013, it would cost you around $3,000 to get a drone, and it effectively would just give you an aerial photo. You couldn't do anything with it because you couldn't change the camera aspect. It just gave you a fixed point in space, which is still really fun. But from then, the rapid development and kind of exponential growth of published papers in science using unmanned aerial systems, or drones as I've been referring to them, has just been an exponential rise. And that is entirely due to the price point. So today, the drone that I use to develop these 2D and 3D models is $1,000. For $5,000 today, you can get a drone that puts together these images with a thermal component. So like you kind of see where as the technology increases in efficiency and decreases in price point, you get more people able to adopt it. So poor grad students could go out there, fly a drone, collect some data, look at tree species. It's just really powerful. And the progression through time, I think, is going to open it up to potentially community science-driven efforts when it comes to drones out in the environments to look at things that we're all interested in looking at. And again, this is a specific example of that price efficiency. And we're looking here at kind of the price breakdown of monitoring crane population. And this same thing could be taken and extrapolated, well, not extrapolated, it's a direct relation to how much it costs to fly LiDAR. So a normal LiDAR flight could cost anywhere between $45,000 and $100,000, depending on the scale of the flight, who's flying it, and a bunch of parameters. So it's a big upfront cost, and it's not very repeatable through time. So you usually get LiDAR flights every few years, or you have to specifically pay to get them into a watershed. Whereas right now, you could get a LiDAR capable drone with RTK or PTK, which are just fancy terms for saying they connect to satellites to add more accuracy. And that's going to set you back roughly $20,000 to $30,000. Now, there's pros and cons to unmanned LiDAR versus manned LiDAR, but the biggest pro with unmanned LiDAR or drones, the use of them, is you're able to have repeatability. You could take it out weekly if you want to in the same place, seasonally, for floods, for not floods. You're able to generate centimeter level accuracy, especially on these modern LiDAR systems with RTK. And again, just kind of emphasizing that quick mobilization. You don't have to assemble a crew. Flight plans are way easier when there's not people in space, and just a device in space. So just when thinking about that flooding seasonality and the rapid site change that we see, like in the watershed of the places that we're interested in seeing as like individuals and as an organization, like I personally, and I think a lot of people around me, including Ryan and Mike in here, we're just quite drawn to this capacity to monitor and the efficiency a single person with a drone could provide these restoration practices. So, like I said, this is going to be like the boring, I get into the nuts and bolts of it. So drones to me, definitely more than pretty pictures. And you haven't seen too many pretty pictures yet. So I apologize if that's what you was expecting. So again, why I'm drawn to that power that these have, like how does it become data? A normal on the ground photo is taken in the X and Y. Like if you've ever set up photo points, you know the coordinates. You also know that the river floods and you can't take those points all the time, especially if you're interested in flood conditions. So having those stationary next to the river is pretty hard. So that's just like X and Y. Now, if we were to add another dimension to those coordinates and put it in space, let's call this the Z. So X, Y, Z, we're putting it up in space now. So not only is it related to the X and Y, but now you have the Z variable. You know how far it is from the X and Y above the ground. So now you have distance in space. So again, I'll kind of relate it back. RTK and PTK simply is adding another dimension to this to fine-tune accuracy. So when you have multiple of these three-dimensional observations in space, you're able to understand distances, areas, volumes by relating these observations to one another. And especially more powerful when we think about applying the third dimension is you're able to change the angle and the focal that you're looking at these objects on the ground. So just overall, like that's kind of the nuts and bolts. I'll kind of give an example of this. This is me pointing at an area above a logwood jam. Some of you might be familiar with this as showing our lovely board members this area. Right over my right shoulder, right above my beloved tie-dye hat is this log jam. Again, this is one observation in time from a ground point photo. Here's a representation of me trying to take a picture of that same thing, imitate a drone, and get that log jam from above. Again, you're like, man, Zach, that looks like an amazing log jam. I just took a lot of cranks on a grip hoist to get those logs in place. So we'll see what happens when we're able to put that Z component to those two photos, because these two photos don't really do too much for us other than give us like, oh yeah, there's a wood jam in the river. So adding that Z component right here in the center of the screen, you kind of see that big jam with the upstream jam built as well. Moving through where now you see the jam kind of top center of the photo on the other side of the river. Now you see the photo, you see that log jam kind of to the bottom right of the photo. And here you see that same jam to the far left of the photo. Taking all of those points in space via the drone, you're able to stitch together this orthomosaic. And again, I apologize for the resolution of this. It's a snippet taken from Drone Deploy, so I had to stretch it to fit the presentation. But you can kind of see that in space. And you're like, oh, that's kind of cool. The drone photo just did that. Why do we have this fancy orthomosaic? It's mainly to see what this site does over time, because I could repeat this no matter the conditions. But if snow on the ground, pretty high flows, I don't have to walk out there. I could set in the truck and look what happened. All that effort, that log jam is no longer there. So just really cool, fun aspect of showing how the X, Y, and Z kind of a practicality of using those orthomosaics to see what happens to some of these projects. And again, that was my best attempt to flare up how these drones stitch together these orthomosaics and kind of give us the power to start collecting data. This is, again, just an observation. And kind of zooming back out, as people that just like to be outside or just use maps to get places, we all use Google Earth, I think. I could say that pretty confidently that we all do that, especially natural resources. It's just so nice to go into Google Earth of a place of interest, look at it, and then if you really want to get fancy, you start looking at those pictures through time. Now, what's really cool is you could add a Z, like the Z component to that same picture using the satellite as a proxy for the drone and topographical layers to add the topography and that third dimension to the photo. And you could zoom around these, like modern mapping systems, like you could zoom around these places and kind of explore, look at slope. I'm interested in this area. This is like my backcountry skiing dream of all season, and get out there a bunch. So like I'm able to gather a lot from this photo, but it's at a really big spatial scale. There's not a lot of accuracy. So kind of imagine having the ability and the power to look specifically at an area with centimeter level accuracy with this same thing. So at that level of accuracy, like you could count pebbles, identify individual tree species, monitor landslide contributions, area to like stream morphology downstream and habitat change. But with anything, especially like with that power of that, like we have these fancy toys, and those toys are drones. And I've told this many times. I'm just really excited. I get out there and I don't have a plan. So like they're just toys at that point. When you have a plan in place, you're actually able to take that toy and generate that data and actually analyze it to like show change, measure what's happening in your system, like whatever it may be. And that's kind of where I get into the example of how Mid-Columbia is using this drone. So I was I kind of came on board onto Mid-Columbia with the Little Nat Cheese project underway prior to implementation. So you have this big project. And if you're not familiar, Little Nat Cheese project that we implemented in the fall of 2022 was kind of on that line of stage 0 to 0.5. And if you were at a previous winter speaker series about that value reset, this project incorporated some of that. So you see the two yellow components of the project, and those are these big levees that were kind of made the Little Nat Cheese in this area half pipe. So they took a D10 and just kind of scooped up the sides, pushed them into these levees. We took that material and regraded effectively between that and clear down below where you start to see this pink and that floodplain kind of expanding. And then we just added a ton of trees, like 1,000 trees that we harvested in the riparian reserves next to the site. So you had this potential there. You're like, well, okay, how do we monitor this? Like, how do we measure project success? What do we do? Do we go out there and take 4,000 ground photos before, after, and through time, like just walking the whole site multiple times? But then we miss flooding. There's all these components. So like we have this area, and that's where like the kind of planning comes in. With Drone Deploy, you have the ability, it's like, okay, I know the area. I just draw a polygon around it. This is going to take 42 minutes. covers 71 acres, takes 740 images, 3 batteries. You can change the flight altitude. You go out there, you press go, and it flies and takes the pictures for you. You're just making sure you have line of sight. So if you lose the drone, you know where it crashes. This system's not, I mean, the recreation is pretty big, but you're not really worried about major highways or anything like that. So you're just making sure the drone's in sight as a safe practitioner of using airspace. So that's just kind of like the back, like the planning phase of this, and like the power that you're just like, oh, you could automate this. This will always stay the same. I could give this to the next person, an intern, and they could go do the same flight and collect the same image and create the same ortho mosaic that I did, even if it's 10 years down the road. And at that point, their drones are probably going to be way nicer. So like here is the most basic and like the most powerful like use of having those photo points with the Z coordinate. To the left, you see the pre-project conditions with an estimated flow of around 260 cubic feet per second. And to the right, you see post-restoration project conditions around 162 CFS. And this was, we got almost a year out, like a year in there. And you look at this and you're like, does this look successful? We regraded the river. You're looking at that picture to the right and you're like, man, there's a lot of wood in there. There's a little bit more snow on the ground, but you see that floodplain inundation at lower flows. And the single snapshot, I think most of us, and historically most restoration projects would be like, yes, that's a success, like move on. But knowing how we are, and we're curious, and the guiding committees and all the stuff and this size of project, and the general public, just understanding and actually defining if the project is successful, holds it to a different standard, I think is valuable when it comes to restoration. So the outlines, like the objectives outlined to achieve the goals that we sought in this project, will kind of give more definitive answers on project success as we monitor it, all of which kind of lead to showing the public, grantors, partners, and anyone interested as they drive by that the money spent is achieving the desired outcomes. If it's not, what lessons did we take from it? Like, what could we do better the next time for the next project, and see where it goes from there? So again, this is my homage to that picture. I still think every slide should have this with aerial photos. As an eagle or wild goose sees it, it just makes me laugh. So while this is kind of going to be the most boring slide, hopefully to you, this is kind of the proposed conditions that we were meaning, like we meant to achieve in the Little Natchez restoration project. To measure all these parameters across time would take just a bunch of money, bunch of capacity, and simply like we don't have that, and most agencies don't have that type of capacity to monitor these projects through time on all the variables. So usually you just get these like little snippets. So how do you monitor every component possible of these landscape changes while we're maintaining a cheap budget, generating good data, and like showing that your project is successful? With the scale and optics of this project, and again, the overall curiosity of myself and everybody involved, using a drone alleviates that. Like I said, I showed you the flight plan takes 40 minutes to fly it. While you're flying it, you could play around the site, play around on the stream, walk it, just maintaining line of sight with your drone, and generate that orthomosaic. And processing time's actually really fun because you just play around and you could zoom in, out, the 3D models generated. It's more like playtime. It doesn't feel like work. And beyond the highlighted conditions in this table that you see, we could also monitor canopy density left in the riparian harvest, which was vital for this project. With the trees being harvested so close to the river, allowed us to reduce fuel costs, the trucking costs, like the whole thing made it streamlined. So holding ourselves to a high standard when it came to like those riparian harvests was important. We could also compare modeled versus actual conditions, monitor and measure wood movement, and learn from the comments, predictions made from the technical group and all the people that came together to build this project, like the efficiencies of the upstream side channel and the mouth of that side channel needing to be wider because it might get blocked with wood. So now that slide's over, I'm going to kind of like go into the coolest story that I'm able to tell from the air on this site, just since we finished the project in like September 2022, and we're just in March. This is still real. It's like this is the coolest part of this whole thing. So this picture you're looking at is the modeled shear stresses, the top picture of the existing, with the red being the highest shear stresses. Pre-project conditions, this area is often referred to as the fire hose. So those shear stresses would concentrate, push all woody material and sediment through the site, and effectively you would be left with a downcut channel, really like uniform habitat with not too much holding water spawning for any of the species of interest, and not too much floodplain inundation when it comes to that area below those shear stresses. So kind of outlining this in the proposed or the existing, the pre-project conditions and what it was supposed to look like after. So in the following slides, we're going to see what this plate, like what it looked like, what this area of the site looked like kind of before project, immediately after project, then a month ago. So here we're looking at the Little Neches area, in that area circled in the previous slide. Kind of got that fire hose, the berm running on river right and left, not too much happening. As you see this, the scroll across the screen, you're going to see post-project conditions, completely georeferenced over top of. You're looking at the low flow channel, center cut, kind of where the water is at, and that is a vital component of this project. And you see all the floodplain wood spread across the site. So this was taken roughly, the pre-photo at 70 CFS, the after photo around 4751 CFS. So pretty cool what you're able to do there. And again, like I highlighted that low flow channel right there, center cut. This is what the project looked like. What the project looked like as of February. So this photo was taken, or this orthomosaic was generated November, and it's just more snow on the site now, but all the wood is pretty much in the same spot. Here you see that the low flow channels getting less defined. You see the massive movement of wood in this area, and again, looking back at the shear stresses that were in the pre-conditions and a little bit so in the proposed conditions. Also, you see that side channel that it's kind of activated down coming in off the left side of the photo. So from what happened in previous years in the existing conditions, that fire hose effect would have pushed all that wood out. Already we've seen in the bottom portion of that where those shear stresses kind of were building up in that bend, that wood was actually recruited really fast there. So as we move downstream in this, now what I'm going to refer to as like the depositional zone that we restored in the Little Neches, we're going to see like what happened there, from project completion to November. And that was that 2-year flow event. So here on the left side of the photo, moving from top down, you see that low flow channel kind of tucking up against the tree line all the way down. Again, deemed necessary for fish passage during the lowest summer, or the lower end of summer flows when fish could still get up to the Little Neches. So just a huge component of the project. So again, as this kind of cursor moves over the project, it's hard to kind of focus, but again, you can see that massive movement in the upper portion of the site, and then effectively, you can't really tell anything's happening with the wood down below it. So just from this, you're like, oh man, that regrading really did something, and that wood placement really was able to catch that material. So it just became the super awesome depositional zone. And again, this is just like fancy orthomosaics, but like, what does it mean for the data that we're actually able to generate from it? So moving back to these measurable objectives that we're able to get from these orthomosaics, the most useful, powerful, and easy to achieve data is floodplain inundation from the modeled versus the actual. So luckily, this site, well, I'm not sure if it's lucky. but the environment decided to just give us a 2-year event, effectively a month and a half after project completion. Being able to mobilize fastly, we was able to capture floodplain inundation at this event, like where the water was flowing at. And what we're able to do is overlay where we were seeing water at versus where it is modeled for the water to be at. So in this upper portion, you'll see that we're actually not achieving in this area the projected outcome that the model showed us. So in that bend, we're likely seeing this increased shear forces that were there prior to the project. So that type of constriction, where as the river comes around, we're like, oh, wow, we're underachieving here. So like, what does that mean? Well, luckily for us is right downstream, we had this depositional zone. We gave the process back to the river so that wood wasn't mobilized out of the site. That wood built 2 massive jams in that project reach between the underperforming zone and the overperforming zone. And we're actually able to already see via the drone that there's fines accumulating in that portion of the site, and it's confirmed when walking the site that there are fines over this whole area in that depositional zone after the regrading and the flow event that we experienced in the fall. It's just like, I don't know, this just gets me really excited of like what this was able to do. Just like me going up there, Bryson's like, oh yeah, 2 to 5 year event happened. I should go up there tomorrow and not have to coordinate anything. Just go up there and fly, have the plan in place, go up there and do it. Just super exciting. So kind of what does that mean for the engineered wood jams? Well, as you saw from the photos, we're able to overlay the as-built design. So you can kind of see the shadow representation of where wood jams were. Now, in that 2-year event, we lost 5 of the 90 to I can't remember the exact number. We lost 5 log jams out of the 90 to 100 engineered log jams that we built. The 3 specifically, kind of in that left portion of the photo, were there to enhance and kind of keep that low flow channel kind of scoured out, provide habitat for fish using it. Project completion, there was some conversations had that some of this wood was actually going to be a fish passage issue. Well, that only lasted for, like I said, about a month before all that wood got moved. Now, those 3 and the 1 additional upstream of those engineered log jams made sense to move. The one that doesn't make any sense to me, and I still can't figure it out, and we have this one in the lower right, that engineered log jam got moved. It could have been a buoyancy thing. We built it with bad wood. That was a joke. I'm not sure what happened there, but it actually doesn't make any sense to me because effectively all the other jams, everything else stayed remarkably in place. And right above that structure, there's a lot of wood side channels to dissipate energy. And the shear force models has like pretty much nothing happening until it reaches that crib wall. So kind of like looking and zooming in to where those 3 engineered log jams in that low flow channel that I've adamantly mentioned a few times thus far in the presentation, we're just kind of going to zoom into that photo. Here we actually do see the cartoon representation of the engineered log jams. Those 3 engineered log jams that you saw got scoured out were, in that low flow channel. From the orthomosaic, we're already able to kind of show that low flow channel isn't as defined as it should be. And, this summer, we're going to be actively monitoring if that low flow channel was filled fully, if it is a fish passage issue, what is actually happening to that low flow channel? Because there's a lot of debates in the valley reset or stage 0 and the stage 0.5 is, when to use these project components in your restoration work. And I think monitoring this and using this as an example of using that engineered low flow channel, which is bordering on that 0.5 strategy, by also trying to build in a depositional zone, like we're able to gauge price efficiency. Was it worth it? It looked like it filled in a 200 meter or about an 80 meter section within a month and a half, the first high flow event. filled it in right in that depositional zone. So this is going to provide insights on future projects that are in those development phases when it comes to stage 0, stage 0.5, and what it actually looks like when you put it on the ground and when you let the river take it back. Like, what's the river going to do to your site? Kind of going more into some objective monitoring. Here you see the 2-year flow widths taken. I've made georeference lines on the orthomosaic, measuring this 2-year flow width. Pre-project conditions saw it at 79 feet before the project. The proposed conditions meant to see 130 or 163 feet wetted width. What was measured across the entire site was actually, during the 2-year flow width, 162.28. So pretty dead on. I'm not sure if I did something wrong or if it's just that accurate. I'm gonna go with the accuracy point on that, because it actually, from walking the site, it is those widths. And kind of moving on to other stream metrics, kind of tying in that low flow and how monitoring that through time is going to be important. We could also make a geo-referenced line through the orthomosaic, monitoring stream migration, slope length, and monitor any down cutting, head cutting, or any of the other project unraveling processes that were brought up in the technical working group meetings and by other experts as potential risks to this project. Here, it should be noted, is actually amazing, because this line, you can kind of see the dotted line is pre-project conditions, the solid line is post-project conditions. That is the area we actually filled. So you actually do see that elevation change in the data, like within the data and in the stream. And the little peaks are, representative of the log jams, but, and the stage height of the water is going to play into this. But monitoring this thing right here, if we look down at the lower portion of the project, we can see if there's any head cutting through time. But we'll pick that up with this profile, which is kind of an amazing aspect, because again, all this is generated by a 45-minute flight. So I want to emphasize the efficiency of me just pressing a button, and I could go ground truth some other points of interest while I'm on site. Kind of moving on to other aspects that you can monitor with those same flights. This is a 3D model showing you trees that are over 50 foot or taller, kind of based upon the lowest position, which would be the stream in this case. And from this, I'm actually going to be able to generate proxy stream shade layers through the entire site. And I could actually use like aspect, how the watershed's positioned, to measure what portions of the stream are shaded and monitor how that shade changes through time, which is quite amazing. And again, possible in this project because the area on what you're looking at here before the project had effectively no trees, and after project, of course, a few months out, still has no trees. But what we've been able to kind of already start to discuss is delaying this revegetation approach that would have taken a bunch of time, money, and effort, and actually monitor if the site is reproducing by itself and we don't actually have to plan it. So that would show us that we've given the process back to the river, which I think would be an amazing accomplishment when we think about this, like stage 0, 0.5, or restoration in general. If we're able to give those processes back to the river, then we could save money, we could save time, and that's what we want to see, because that's going to lead to longer term uplift for the sites. Kind of circling back to meeting those prescriptions, we did utilize riparian reserves in this, which have to follow strict guidelines on what canopy could be left for ESA listed species, in this case spotted owl. When talking with the Forest Service, is actually quite impressive that doesn't really get monitored that much unless you do something drastically wrong. Again, holding ourselves to a higher standard, which I think a lot of projects need to do when it comes to all components of them. We were able to kind of use those same flights we used for the stream, and we're, again, actively planning to do all the area that we harvested from And from this photo, you're able to see before harvest conditions, after harvest conditions. Now you could go through this in general and just digitize canopy layers and see what canopy's left. But where it becomes really powerful is you could leave that up to the software where you just have pre-post, this is the post condition, where you just digitize the red area where the drone's picking up the ground and then compare that over your entire area. Then you're able to see if that prescription's met. You can measure gaps in that canopy and kind of show that you're meeting those EA decisions, meeting those prescription standards when it comes to ESA listed species, even though that we're interested in the river. I think, making sure the forest overall kind of goes into that process-based restoration where everything's kind of playing on each other and is important for project success. This is a sore point for me. I think some folks in here this should be recognizable as Crow Creek. It is immediately downstream. It experienced that same 2-year event. Now, we pulled all these trees in that you see in the green photo by hand with a grip hoist, and that takes a lot of time and effort. And there was some other stipulations put on the project where we couldn't harvest trees within a certain distance of the river. So all this was an immense effort, and this is only a portion of the project site. Now, as this scrolls over, you will just quickly notice that all that effort in this reach was effectively lost in that 2-year flow event. But we're able to learn from that. So in looking at stream slope and stream power, if I would have went out into this site it's a transport reach anyway, but there's portions of this site that we could have loaded more with wood. Mike brought up a good point that we could have steered away from potentially building structures and just putting wood in the system and letting the river sort it out, which is kind of what it did. It should be noted, we went out with a silviculturist with the Forest Service. He deemed a few trees that were over 15-inch DBH that we could cut. And those trees were around that 18, 19-inch DBH, and one snag that was around 20-inch DBH. All 3 of those stayed in the system. So if a future project were to occur here, there'd need to be discussions to get wood that's bigger into this stream to keep it there to actually provide the habitat that we sought to provide with this project. All right, so all that in summation, what is needed by anybody that wants to go out there and do it? If you want to fly a drone for your job, you need a Part 107. It's an interesting test. I quite enjoyed it, as I like looking at weather and reading maps. So I enjoyed that part. A capable drone, like I mentioned at the beginning of this presentation, $1,000 gets you in the door for a drone of capturing this data. And you could scale it up to, LiDAR centimeter level data if you have the budget. Software to automate the process. There's a bunch of different ones. I think Ryan will cover a few of those. The ability to press a button with that. It's, again, like I said, you take the test, you get the software, you get the drone, you press a button, it flies it for you. And the understanding you will crash the drone. You can do everything you can to not do that, and it's best practice to not crash your drone. But things happen. It's technology. It's computers in wilderness spaces. Ideally, you have that line of sight. The drone you see there, I crashed a few weeks ago trying to get some orthomosaics for a closeout report, and I spent a better part of a weekend trying to find that thing and in the woods and the snowpack. So lots of fun. So it's something you can look forward to and expect. And I'm going to kind of wrap up with the future of UAS. I kind of mentioned ChatGPT and AI, where you plug in what you want. A friend and myself are working on taking these orthomosaics, the engineered plans, seeing the before and after, and however many orthomosaics you have leading up to it, where you could ask an AI program to be like, I want you to show me what the little Nat cheese will look like in 10 years. I want you to show me what Crow Creek will look like if I put 18-inch DBH logs in there. Like, there's the potential to do that with these orthomosaics, AI, engineered plans and kind of encompassing and having the computer go in there and look and render these sites for you. And I think the power of that's going to be very, very applicable to natural resource stuff. But again, I could be in that portion of inflated expectations. And with that, I'll turn it over to Ryan as I pull up his slides.
Thanks, Zach. Good stuff. I think we're a little short on time here, but so if you have to bounce, no worries. You're not going to hurt my feelings. I'm going to jump around to a few different sites in the Kittitas County area, and we'll start with this rather unremarkable deck of logs that I snapped with my iPhone. As with most floodplain restoration projects, wood was the medium to produce the desired outcomes. At this site in the North Fork Teanaway, returning wood back to rivers can be pretty challenging. In this case, we employed a helicopter to transport logs from the main landing to the river and to temporary staging areas. Seems easy, right? The trick on this one was we had wood that was going directly in the river, and then wood that was going into engineered log jams that had actual engineer specs. So there was actually a whole log schedule that we were trying to meet. Next slide. And I think I figured it's like $2 per second to run a helicopter, and that was a few years ago. So coming with an efficient communication tool between the biologists in the creek and the loggers at the landing was pretty critical here. So this is that same deck of logs from about 150 feet off the ground, and there's certainly more information here. It's an interesting photo, but it's not super useful for what I was trying to do. So next slide. So my project partner, Rebecca Wassel at Mid-Columbia Fisheries, and I went out and bought a bunch of spray paint, painted the butts of these logs different colors, and then I brought that drone photo from the last slide into ArcGIS and color coded the decks. And so each of the choker setters at the landing had a copy of this map. And so when biologists called up an order of logs from the creek, the choker setters knew exactly what we needed, and they'd bring the right materials to the right spot. There's really nothing worse than creating a deck of logs in the wrong spot and having to relocate that deck of logs again. But I thought this was a pretty interesting example of how we use drones to communicate, and you can see how happy Dr. Dan is in the lower right. I'll talk a little more about him in a bit. Next slide. So this next example is a pretty urban setting for me. This is in Ellensburg on Mercer Creek. Mid-Columbia Fisheries had recently been able to squeeze a floodplain restoration project into this small space and wanted to be able to efficiently monitor it over time. So using flight planning and image processing software, drone deploy, as Zach spoke about earlier, we flew transects autonomously to collect about 427 images at the site. Next slide. So this is like immediately post-construction. Hasn't had a lot of activity with flows and such, so it's looking pretty rough still. But those 427 images were mosaicked into. Hopefully, you can kind of make out the edge of that mosaic, and we're able to set the stage for repeat flights and ultimately quantify change at the site. Next slide. And then for this particular orthomosaic, we were able to achieve 0.74 inches per pixel resolution, which is pretty tight. Mid-Columbia Fisheries staff will be able to quantify morphological changes, vegetation responses, and a number of additional variables over time. Next slide. And if you really want to be super precise in the X, Y, and Z planes that Zach spoke of earlier, ground control points are necessary. And so this means, at least in this case, surveying in control points with known horizontal and vertical datum with survey grade instruments. And then as you can see on the left, that's just a 5-gallon bucket lid that I spray painted a grid on. You take that and place that over the ground control survey point, and then you pay an extra $50 when you have this image processed in drone deploy. So what it does is it puts the photo in the exact right position, and then it also gives you really super precise elevation data. And so each of those bubbles, you just basically frame your flight area with ground control points. Next slide. So the Z value, with the Z value, we can produce these photogrammetric surfaces. That's a really hard word to say, by the way. That are in the right spot, as I mentioned, and so this is a digital terrain model output. So essentially, most of the trees and vegetation has been removed. And the accuracy is really important when you're comparing different surfaces through time, because if you're off by a little bit, that can turn into thousands of cubic yards more material than was actually present. And this, I'm still kind of trying to get used to this technology. The surfaces that these produce, they're so precise that they actually pick up blades of grass, and they kind of cause a lot of noise. It's like too precise. And I've even heard that if you took one of these images and we snapped a line across the road, you would actually pick up the paint lines on the asphalt. I need to try that at some point. But to resolve that at this site, Central Washington University staff and students are working with Mid-Columbia Fisheries to do repeat survey work where vegetation becomes established, so we can essentially erase that vegetation from the surface and then compare the surfaces year after year, or big flood after big flood. Next slide. And here's an example. This is upstream of Tainum Campground on Tainum Creek. And the lower panel is what's called a digital surface model, or a DSM. And the trees are still present in this output, which can be pretty powerful. Just another example of what we can produce here. Next slide. So that's not me in the plane. I wish I had a plane, but it's just a cheesy photo that I thought was funny. But the big theme of my talk here is how you can communicate really well with drones. But I also want to toss in some lessons learned. And when you go in to take your Part 107 exam that Zach spoke of, they test you on these hazardous attitudes, and they seem pretty obvious. I'm not going to go through them all, but you know, they're pretty important. And in this next slide, I'll kind of talk about how I've entered the gray area on the invulnerability attitude. This is another ortho from further downstream on Tainum Creek. I flew this mission when there was freezing fog rolling through. So I had kind of time it in between clouds of fog. And if you look kind of on the right, you probably can't make it out in this slide, but if you zoom in, you can totally see fog obscuring the image a bit. But we had a topo survey done in last summer so that we could produce an engineer plan at this site, but there was some gaps, and we needed to further articulate where the bank lines were. And so we really needed to get this this drone flight done so that we could delineate those areas. So I was kind of in a mad rush because we had deliverables due, and kind of push the limits here. It's okay to fly drones when it's really cold. It's just when it's really cold and you have high humidity, it can cause your rotors to freeze, and you could have your drone just plummet from the sky. Luckily that didn't happen, but like in between battery switch outs, I was like having to scrape ice off the propeller blades each time, and it was kind of sketchy. Next slide. But yeah, like I say, in the end, we were able to generate the data we needed. This is just a hydraulic model output for depth, but this was sort of existing conditions, and just getting to this point was pretty important, but probably worth the risk, but something to consider if you're looking to get into this sort of work. Next slide. This is my last Tatum Creek example. This is just upstream of I-90. This was a multi-day effort. This slide doesn't cover the whole extent, but there's probably 2,500 photos. Took me about 4 days to get all this. And one of those days it was super hot. It's probably 100 degrees plus. Perfect day for flying, right? Well, I guess when it's really, really hot, it can cause you to lose connection with the drone, between the drone and the remote. So you have no control. And so luckily I was able to like use the emergency return home button. A big deal when you're flying drones is not to panic ever. And then maintaining that line of sight is really important. So if it does plummet from the sky, you at least know where to go retrieve it. Next slide, Zach. So this is probably my most interesting slide that Dr. Dan Scott put together. He performed as part of a regional study on wood and rivers. He picked North Fork Teanaway as one of his sites. This is up near Stafford Creek on the North Fork Teanaway. In the upper panel, you can see site conditions immediately following the addition of just a handful of logs there. And then the middle panel shows conditions the following year. And in this panel, Dan was able to actually detect shifts in substrate composition, which are represented by the dotted line polygons there. These are areas where substrates become finer since the project was implemented. This is really important in this system because of the historic removal of wood, channelization, beaver removal, all kinds of human-caused impacts. That's produced a situation where smaller gravels just weren't being retained and essentially just getting evacuated each elevated runoff event. And these smaller particles are really critical, as most for spawning and habitat complexity, bar formation, and other things important for cold water fish species and floodplain connectivity. Anyway, the bottom panel, kind of common theme, wood moves around a little bit. But you can see all that wood sort of, or most of the wood move downstream to that, the nearest change in channel grade, also known as a geomorphic nick point, and it's produced this beautiful log jam, and you can probably make out that gravel bar that's formed upstream of it. That's a spot I'm going to be personally watching for a long time. It's pretty cool to see. But this is just a really cool example because it's super simple, it's repeatable, and the results are pretty compelling, and you can actually quantify things. Next slide. So I'm just gonna, excuse me, just gonna finish up with a few, call these glamour shots. These are just obliques of the North Fork Teanaway. I think relative to photos from the bank, they're just so much more powerful. They really tell the story of how wood functions in rivers. Like in these, you can see the velocity heterogeneity and deposition of gravels and elevated water surface elevations. It's just pretty telling. what does strike me though, in all of these photos we've looked at, is how tiny the wood looks in these rivers. They look like twigs. That's probably a whole nother talk, but pretty cool stuff. So this is actually just upstream of Highway 10, Swat Creek. I just wanted to point out that there's lots of training resources available. I've attended 3 courses with Dart drones. They're a good company. They're not super expensive. Next slide. And then let's see, I wanted to mention some flight planning and image processing software. Talked about Drone Deploy a lot, but Pix4D is a pretty common program. And I recently learned that ArcGIS Pro has a flight planning tool and image processing capability. Unfortunately, all these programs are not cheap. I mean, I know Drone Deploy is at least $3,000 a year. So you have to be pretty serious if you want to get into creating orthomosaics and making surfaces out of your drone products. But hopefully Zach and I have shown that, you know, you can communicate a lot just with Glimmer shots. Yeah, and then just also working in forested or these wild areas, it's really difficult with regards to drone work. They're I feel like they're designed to have a cellular connection. That's not to say that you have to. I think most of the work we do there is no internet or cell phone, but definitely makes things easier. And then if you're ever working around a military installment, they can be really challenging, even if you have all the correct permissions. They set up these invisible geofences that'll just like stop your drone dead in its tracks, and yeah, just really challenging there. And then I've had several crashes. I think the Little Natchez is the Bermuda Triangle of drones. That's where I lost Yakama Nation's drone several years ago. I didn't find ours. It's still out there probably, but crashes happen. But they're pretty hardy, and you can usually get them fixed for pretty cheap. That's all I got. Any questions?
Thanks, Brian and Zach. That was awesome. So interesting. It's a lot to wrap my mind around as like a not super techie person. So there was a question from Kristen Kirkby in the chat. She embedded several questions in here. We did sort of answer the one about software, but what resources did you use for learning? And is there a lot of processing involved?
Yeah, well, I mean, the resources for learning beyond the Part 107, which is like kind of an interesting test. I studied for that via watching YouTube videos. So I'm very much I guess a techie person. Just Google it, you can learn it. For the processing, if you didn't have the software, as in Drone Deploy, Pix4D, or ArcGIS, or there's like DJI Terra has software out. There's quite a bit of processing. What the software does is allow you to have the flight plan, but you just plug your drone up to the computer, upload the images, and it processes it for you. So then, like Ron and I both use is Drone Deploy. Right, since it processes, it makes the orthomosaic, and then you just click buttons in it, and you can put on the elevation layer, plant health layer, contours, and you could explore your site or sites. Like I could explore the Little Natchez and Crow Creek within the same map. So it's makes it pretty nice via that. And that makes it very plug and play in my mind, because I could just have an intern or anybody, like if I want to have a little cousin come out, he could go up there and fly actually he could, because it'd be for work. He uses Part 107. But and like Ryan gave me pictures, like for Mercer Creek, he just sent me a file of pictures. I plugged them into Drone Deploy and replicated his orthomosaic that he generated on his end. So I hope that answers it.
Yeah. That's really helpful. Ryan, I love the Mercer Creek pictures. Thank you. And the glamour shots. They're all great. Let's see. There is a question from someone about the 3 courses, Zach, the 3 courses you mentioned, but maybe Ryan caught that answer in the chat.
Dart drones. Dart drones. They're, they've got courses on roof inspections, 2D mapping and modeling, and then just like basic stuff on how to fly a drone and how to pass the FAA exam. For a biologically minded person such as myself, I don't know, Zach, that test was kind of hard, man. You got to study. You have to read these sectional charts that real pilots have to know how to use, and they're pretty abstract to me, but I think it just takes the right personality.
Yeah, Michael Hannigan from our board put in the chat that it seems like an efficient way to gather data and just responsive to floods, and being able to look immediately after a big event is really powerful.
And I guess for the expense of the automated or like the software, I was luckily able to commandeer a nice discount for Mid-Columbia through Drone Deploy, but also help with some development of stuff for them and like feedback. So I try to participate in what they do. So it makes it a little bit more efficient.
Michael Hannigan also asked about if you're using drones at control sites.
Like having reference sites like upstream or downstream?
Well, the question continues. It might be interesting to compare similar landscapes to see the impact of your work in real time to similar sites nearby.
Yeah, I mean, I don't do that. It could be added, but what you get in with that is battery capacity. So just flying the little Nat Chi site drains all the batteries that I have, and to charge them takes time. So it's just like a multi-day effort at that point. So you would kind of lose some of those efficiencies in doing that. But yeah, if you had a surplus and a few $1,000s worth of batteries, yeah, you could do a whole watershed in a day.
Other questions, folks? Oh, here comes one from Stephen Eddington. Hi, Stephen. Thanks for coming. What was the software you used to draw flight paths? Was that also Drone Deploy?
Yes.
Yeah, and I was going to mention too, Zach's almost touched on this, but when you draw that, so you got this area that you want to fly, draw a polygon around that, and then you go in and you can tell it how much side lap, front lap you want, so that you every photo overlaps the next front and side. And I usually go like 80% and on the front and 80% on the side, just to get a good image. I'm not sure what do you ever play with those, Zach? Those settings?
Yeah, a little bit. It depends on the vegetation cover and how much blur I want in those pictures. You can kind of clean up some of that tree canopy by doing that. And primarily, I play with it when it comes to the site size. Like little Nat Chis, I don't have much wiggle room for batteries.
Are there folks in the audience that are using drones to monitor habitat or landscapes? Stephen? Nope. Apparently not.
Can you hear me, Margaret?
Yeah.
Hi. So yeah, I'm starting our drone program at my new place of work. And actually, like, this is developing this week. I'm working on obtaining my part 107, and we'll be using it to monitor conservation easements.
Awesome. Great. I hope this was helpful.
Yeah, if you need a chat, or we can meet in Ellensburg and next time you come down.
Yeah, no, I definitely would love to pick your brain and Ryan's brain. And I'm coming to the symposium here in next couple weeks. If see you guys there.
Great. Yeah. Other questions, folks? I thought this was really interesting. So not seeing any immediate other questions. You guys know where to find us? Oh.
I just wanted to quickly just mention to Zach and Ryan, I mean, this is not a question, but in white salmon, we have like an internationally recognized drone company. And I don't know a lot about what kind of programs they have that might be, I guess what I'm saying is I'm willing to go do a little work and see what they might be able to do to help you guys out. So I'll run this by a couple of people I know work there and see if they can do anything. They might not be able to do anything at all, but the company is called In Situ and they're owned by Boeing. So it's a big deal, but we'll see what we can find out.
Awesome. Thank you, Michael. I can put you in touch directly with Zach too.
Okay, cool.
All right. Well, thank you everyone for coming. I think we might have gone a little longer than advertised, but it was well worth it because that was super interesting. So Zach and Ryan, thank you. Thank you.
Welcome. Thanks for everybody coming out and sticking the extra few minutes.
Yeah, have a great night, everyone. We'll have this recorded and on our YouTube channel, so you can listen to it again if you want.